Hi, today we're going over section 1.5, which deals with proofs that are not valid. So this is when someone's gone through to show a conjecture works with variables and their proof looks like it makes sense, but there is an error in their proof. So an invalid proof is a proof that contains an error in reasoning or contains an invalid assumption. So essentially, error in reasoning is usually a mathematical error, and an invalid assumption is building the proof off of something that is not true. Okay, so for example, a student claims they can prove that 3 equals 4. They started with saying, suppose that A plus B equals C. They then rewrote it as 4A minus 3A, which gives us the A here, plus 4B minus 3B, which gives us the B here, equals 4C minus 3C, which gives us the C here. They then reorganized this as we moved all the 4 to one side. So we've got 4A plus 4B minus 4C equals, then they moved all the 3's to the other side. So 3A plus 3B minus 3C. They then factored out the 4 out of every term. So A plus B minus C equals, we can factor 3 out of every term on this side. So we have A plus B minus C. They then divided both sides by A plus B minus C. Which then gave us 4 is equal to 3. So now we want to show that this is indeed an invalid proof. So mathematically, it looks like they did rearrange an equation correct. However, in some cases like this, whenever we are dividing something in an equation, there we need to go back and double check to see what exactly we're dividing by. Because if we have A plus B equals C, which is taken from up here, if I was to rearrange this, if I move the C to the other side, that gives me A plus B minus C equals 0. Then technically here, A plus B minus C is 0, same with here, which we cannot divide by 0. So no number can be divided by 0, so therefore, this is an invalid proof. And would be an error in reasoning. Next example, a student claims that 6 equals negative 6 because her proof was negative 6 equals 6. She squared both sides and got the same thing, and therefore negative 6 equals negative 6. Now, with this, her error started in the very first line. So we can never start a proof with what we're trying to prove. That's considered a false assumption. So she started with what she is trying to prove. That's a false assumption. And then essentially everything after a false assumption doesn't matter, since the premise that was built on isn't true. So essentially everything after false assumption is not true because what we're building on isn't correct to start with. So if you're trying to prove something, you can't start with what you're trying to prove. So if an assumption is not true, any argument built on it is false. And in this case, the example we had is essentially circular reasoning. So we're starting with an error, and then by saying that error has been proved. So we start with an error and end with claiming we've proven it. Okay, another example, a student is trying to prove the following number trick. The trick is choose any number, add 3, double it, add 4, divide by 2, take away the number you started with. Each time doing the trick, they end up with 5 as their answer. The proof doesn't give the same result though. So next page, we will look at what their proof was. So their proof was choose any number, add 3, double it, add 4, divide by 2, take away the original number. So they put in variables. So choose any number, they chose the variable n, add 3, they have n plus 3, doubling it, they've got 2n plus 6, so they doubled each of those. Add 4, they added 4 to the 6 to give the 10. Divide by 2, they wrote 2n plus 5, take away the original number. They ended up with n plus 5. So if we look through, pretty much we can see where they made a mistake. So like we said, they added 3 here, they doubled both things here, they added 4 here. Dividing by 2, they divided the 10 by 2, which gave the 5, but they forgot to divide the 2n by 2. So this should really be n. And then when they take away the original number of n, this should be gone, giving us 5.